now that we know what arrays are, let's pull all of this together into the following application. So we have a row of buttons which are either on, green, or off, red, and we want to toggle them on or off by clicking on them. So really it's just an extended version of the light bulb example from the workshop the other week, only instead of using a single light bulb, if I play this, here we go, you can see how we're toggling the buttons by clicking on them, and we can turn them all on and then turn them all off, and then turn another one back on. So let's think about our algorithm. What do we need to know? What information do we need to record? Pause the movie and have a think. Well, in order to make a decision about each button, we need to know whether or not the mouse pointer is over it when the mouse is clicked. And for each button, we need to know its state, either on or off. And we also need to know the size of a button and so on in order to lay them out properly on the screen. But these are the two most important things. But the hardest part is doing one, detecting whether or not the mouse pointer is over a button. Now, because it's not a good idea to hard code values of button locations into your code, because if things move around or the window's resized, locations may no longer be accurate. So it's always a good idea to try to keep things as abstract as possible and to derive locations of things from some fixed anchor point. So rather than saying this thing always goes here in this fixed absolute position, it's good practice to say this thing goes here relative to this point. So in this way we keep things scalable and easy to update, but it does come at a cost of slightly complicating how we draw things. But let's see how it works in practice. So here's a schematic depiction of our row of buttons, which are numbered from 0 to 4. Okay, and button number 2 just happens to be on here. So the button size is 50 pixels. So each button is a pixel 50 square. It is 50 pixels square. Sorry, 50 by 50 pixels. And that's all we need to know in order to lay these out properly. We don't need to specify the location of each button individually. If we know the size of an individual button and its position in the queue, if you like, we can work out its position on the canvas. How do we do that? Well, each button is a rectangle which is specified with an X and Y coordinate at its top left hand corner. So clearly the Y coordinate is the same for each button. Okay, so the only thing that changes is the X coordinate of each button. See that there? So for some button which is indexed I, the pixel location of its top left hand corner is I plus 1 multiplied by button size times 2. So let's break that down. So the I plus 1 allows us, the I plus 1 allows us to get the inset. So there's an inset here. So anything multiplied by 0 is 0, and we start indexing buttons at 0. So we add 1 to the button index, and that gives us half of the inset, and the button size times 2 means that for each button we essentially jump across 2 button widths at every iteration to give us a gap between buttons. Okay, so the first plus 1 gives us this half of this inset here, the second gives us this bit here. So let's think about how this works just for the first button to give a sort of concrete example. So the first button has index value 0. So we add 1 to that to give 1, and then we multiply that by button size times 2. So button size times 2 is 50 times 2, which is 100. So that gives us 1 times 100 equals 100. So that's the X location of the first button. The second button has index value 1. So we add 1 to that to give 2, then multiply that by button size times 2. So that's 2 times 100, that's 200, and so on. So you can see how by simply knowing the width of a button and its position in the queue, we can locate each button on the screen in the row. So what's our algorithm to detect whether the mouse pointer is over a button or not? So if you cast your mind back to the light bulb example, pause the movie and have a think, but bear in mind what we've just said about how we draw each button. Well, here it is. So whenever the mouse is clicked, we do the following. Okay, for each button I, so each button is indexed by I, we calculate its X and Y location. That is the location of the X and Y of the top left of its rectangle. So we call this X and Y. So for each button I, okay, we work out what the location of the top left hand corner of the button is, and we use the formula that we've just seen. Okay, then if the mouse pointer is in range, that is the mouse X is greater or equal to this button's X, and the mouse X is less than or equal to this button's X plus the size of the button, and the mouse Y is greater or equal to Y, and the mouse Y is less than or equal to Y plus button size, then the mouse is over this button I. So record that fact in some way. Okay, so we need to essentially change the state of that specific button because we've detected that the mouse pointer is in the rectangle representing that button. So given that each button is either on or off, we use a Boolean variable to record each button's state. Now we could use an integer 1 or 0, but a Boolean is more conceptually correct because it's true or false. So to store a bunch of states, okay, we use an array of Booleans, one element per button. So in this way, all the draw function needs to do is check the state of each button and draw it in the appropriate color, nothing else. There's no other processing to be done. Remember, the draw function should be as lightweight as possible. All the real action happens in the mouse clicked function, which is only called when the mouse is clicked. So as soon as that's triggered, we simply check each button in turn using the algorithm that we've just described, and as soon as we find the button that the mouse is over, we record that fact, we flip its state. Now, of course, we have to remember that the mouse might not be over any button, in which case we don't take any action at all. So here's the code to set things up. We declare a constant for the size of a button, here, and one for the number of buttons, here, 5. We then declare the button state array of Booleans so that it's visible throughout the entire sketch. Okay, we don't declare it within a specific function where it would only be visible within that function. So by declaring it here, it's visible throughout. Okay, it's a global variable. So in setup, we set up the canvas size here, in this case to 650 by 300, and then we create the array. So we create the array of Booleans, okay, according to the number of buttons, and then we set them all to false. So here we have a for loop, which basically says loop over the array from 0 to numButtons minus 1, essentially, okay, incrementing the index by 1 at every iteration around the loop, and we set the ith button state element of the array to false. So that clears the array and basically sets all the buttons to off. So here's the draw function, and notice how that's all it does, just draws the buttons in a specific color for each button depending on whether they're on or off, nothing more. Okay, so for each button, so we iterate over each button, and if button state I is true, then we set the color to green, that's because it's on. Otherwise, if button state is not true, it's false, we set the color to red, and then we draw the button using the formula that we've already agreed. Okay. So this is where really all the action happens, and it's quite complicated on first inspection, so we'll take some time to go through it. So you'll notice how I've included some diagnostic print statements here, which I later commented out. just to allow me to check the precise location of the mouse pointer whenever it's clicked, and that's quite a useful thing to do. So we've introduced a new variable here, which we call which stores the index value of the button that's clicked. Okay, and we initialize this to -1, because if we initialize it to 0, then it's essentially referring to the first button, which is 0. So -1 is a way of saying null or non-existent, as it's impossible to refer to a negative element of an array. So here we see how we calculate which button the mouse is over when it's clicked. So we use exactly the same method as before, only this time if we detect a hit, we record the number of the button that was hit. So remember, we are looping over each button in turn using the index value I, and if we detect a hit, we need to record the index number of the button that we're currently checking. So we're basically saying button 0, is the mouse over you? If it isn't, go to button 1, button 2, button 3, and so on. So because the mouse can only be over one button at a time, okay, if we detect a hit, then we set the which variable to the current index value of the button that we're currently checking. Okay, so we copy I into which essentially saves that value. Then if which has changed from -1, that is, we saw a hit, then we know that there's been a button pressed, so we simply change the state of that particular button to its negation, so we flip it. Okay, so which, every time mouse is clicked, essentially which is cleared, and then we go, okay, button 0, was it you? Button 1, was it you? Button 2, was it you? Button 3, was it you? Now, the mouse may be clicked on a region that isn't over any buttons, in which case, by the time we've done this checking at the end, which still has the value -1, because none of the buttons have detected a hit. Okay, but if the mouse was over one of the buttons, that will be detected, and the index value of the button that was being checked, where the hit was detected, here will be stored in which. Okay, so if which no longer has the value -1, then we know that one of the buttons was hit, so we need to flip its state. So the which variable is important as it allows us to record whether or not something happened. And we can also note that nothing happened by initializing it to this impossible value. So if it's still at that value when we finish checking, then we know that nothing happened. So what I think you should do now is pause the movie, get the buttons code from the Lecture 6 code on Blackboard and play around with it. Change the size of the button, don't make them too massive, but play around with the values, say 5, 20, and then back to 50. And note how everything still works even after you've made that change, because we've derived all of the positions from first principles rather than hard coding them in. So just by changing one constant, the size of a button, because we've derived everything, the locations and so on, from the index and the size of a button, we can change the size of the button and make it very scalable, and everything still works by just making one change. And this is very powerful, and hopefully you can see the benefit. So obviously it makes things a little bit more complicated in terms of placing things and detecting where things are, but actually I think it's a much better way of doing things. So try it out.